Okay, so probability trees and the and or rules, Maria, right? So we'll start with a question to illustrate the whole thing. And the example is a bag contains 10 blue counters and 5 red counters. Okay, and I'm going to swap colors there. Hang on a second. Get my red one there. All right, so 10 blue, 5 red. Okay, you're going to pick 2 counters are picked without replacement. Now that's important. And I'll come back to why that's important in just a minute. All right. And we want to find A, the probability of getting 2 blues in a row. All right. So in a row. And then the second part of the question, only 1 blue. All right. So that means exactly 1 blue. All right. So the first thing we need to do is, given the 10 blue and 5 red counters, is do a probability tree diagram. All right. The first split over here, that's your first pick. All right. And then the second set of branches are your second pick. All right. So first pick, second pick. All right. Pardon me. Okay. So now remember, from the question, we had 10 blue counters and 5 red counters to begin with. Okay. What do you think the probability of picking a blue is?
1/3.
The other way. You've got 10 over how many? Out of how many in total?
15.
Right, so 10 out of 15?
2/3.
2/3. Well done. All right, so if that's 2/3, how much is this one going to be?
1/3.
Excellent. And that's the rule, that if you have 2 outcomes, or however many outcomes, the probabilities must add up to 1. All right, okay, so that's fine. Now, if you've picked a blue, so let's say you've gone with that one first, right? That's what's come out of the thing. In the second pick, now here's the important bit. We are not replacing the counter. All right, so we've picked a counter, and this time it's been blue. So how many blues are left?
9.
Excellent. How many reds?
5.
Brilliant. So what's the probability of picking a blue?
9/14.
Excellent. And so the probability of picking a red?
5/14.
Brilliant. Okay. And if we had picked a red to start with, all right, how many blues would be left for the second pick?
10.
Sorry?
10.
10. Good. And red?
4.
Brilliant. Good. So again, the probabilities, I'll save you the time on that. So it'll be 10/14 for the blue, and it'll be 4/14 for the red. All right. So now we've got a fully completed tree diagram for the 2 picks. All right. So the first one and then second one. Now, there are 2 things to note here, as I said earlier. It's without replacement. That's really important because that means the probabilities will change. All right. So after every pick, you've got to recalculate or work out the probabilities again. All right. Okay. So we have all that now. And now we're going to use that diagram to actually answer the question. All right. The first part was the probability of 2 blues. All right. So the way to write that is that you want a blue plus another blue. All right. So we know the first one, right, is a 2/3 probability. Okay, so there. All right. So 2/3. The second blue, right, because we've picked a blue already, the second blue is that one there. All right. So 9/14. Okay. Now the question is, this thing, this plus, do not put a plus here, right, in the middle. Right? The plus means a blue and a blue. Okay. Right, two blues. So blue and blue. The and in probability means it's a times. All right. So if you have two events must happen together, all right, it's an and the and means you times the probabilities, you multiply them. Okay. So that effectively gives you, let's just do 6/14. So what does that come to? All right, let's do it properly. Reduce that all down, right? There's your answer. 3/7. All right. Does that all make sense so far?
Yeah.
Any questions? All right. Mariam Bate, any questions? No? All right. So that's the first one. That's where you have a combination of two events, all right, happening, and means you times the probabilities. The second one, it's slightly different. You want the probability of only one blue. Okay? Now, this time, I'll write a bit differently. The ways that we can get only one blue is, and let me just change this. We can go with a blue first and then a red. Okay? Or we can go with a red first and then a blue. Okay? So we have two different options, right? Two different possibilities to get the same result. Okay? Whenever you're doing this kind of thing where you have different choices, you have to make sure you consider all the possible ways of getting the result. All right? So in this case, I'll go back to my red. We want either the probability of a blue and red, or, whoops, probability of red and blue. All right? Now, in this particular example, you've got the and for the two events together, and you've got the or to show that you've got two different options, two different ways of getting to the same result. All right? So in this case, using our diagram again, we want a blue first and then a red. So the blue first we know is 2/3, all right? And then the red after that is that one, 5/14. All right? So what we've learned about and already, so the blue, 2/3, and means timesing it, and that is 5/14 for the red. Okay? So that is the probability of getting a blue and a red in that order. All right? So order matters. I better put that in there. Okay? Next one, the probability of getting a red and a blue. Again, going to our diagram. Getting a red first is 1/3, and then getting a blue is 10/14. All right? So putting that in, 1/3 times 10/14. like that. All right. Now we have this option, or we have this option. One or the other. Both will satisfy the requirement. But when you have choices and you say you have this or that, you add the probabilities. All right. So you get your combinations and you add the different combinations. All right. So or, I should put it in, means add the probabilities. Okay. Make sense so far?
Yeah.
All right. So just calculating that out now. What have we got? 7, 3, 5 over 21, I think.
That would be 10 over 21.
Which one? This one.
Oh, you simplified it.
Yeah, sorry, I did it in one step. All right. So 10 over 42, all right, is 5 over 21. Okay. And the second one, again, it turns out to be the same, 10 over 42. So again, 5 over 21, right? And the result comes to 10 over 21. Does that all make sense?
Yeah.
Yeah? So with tree diagrams, okay, make sure you put the tree diagram together first properly, right, if you need to. The question might ask you to draw it, or in GCSE questions, often they give you the diagram and they ask you to fill in the probabilities, all right? If there is replacement, right, then the probabilities won't change. If there's no replacement, then the probabilities will change. All right. And so you have to take that into account and then just look at the path. If you need to, draw a path and say, I want this first and that first, like which branches you're going across. All right. To get the result. So if you're combining two probabilities, right, you can see that and means times the probabilities together. And then if you have choices of options to get the same result, right, with a different order of the same result, then if you have an or, it's adding the probabilities, as you can see. All right. Any questions on that?
No.
No? All right. Mariam, any questions?
No.
All right. Fine. There you go. Probability tree is done for you with and or rules. All right.